So for more practice, instead of just simplifying an identity, we can also answer questions like, is P or Q and not P a tautology or not? So here, this question here is asking us to figure out if this thing is true no matter what the truth values of P and Q are right here. And we could do that with a truth table. But remember, we're trying to abstract things away and get away from truth tables. So instead, let's go ahead and use these identities over here to see if we can't prove that this thing is a tautology. So again, I'm going to write down this expression. And I have this expression right here. Fantastic. Well, looking at my identities, I see an or and an and that makes me think of, oh yeah, like the multiplication and addition example. That's, I can use a distributive property. I can distribute this or over this and right here. So that's the first thing that I'm going to do. I'm going to distribute this P or into this expression right here. So again, you want to think about distributing this into that expression right there. So we're going to get P or Q and P or not P right here. And the identity that I used was my distributive identity. Fantastic. So, this one right here, P or not P. This is what I mean about not memorizing those identities, but understanding them. If you think about it, P or not P, that's always going to be a true statement, right? Because this is an or, so on either side of it, if it's true, then it's going to be true, and all this not does is flip the value. So in any case, this thing right here is going to always be true. So I don't have to memorize that identity. I can just understand and apply it. And I get this. So this was our negation law right here. Now, let's see here. I have this expression, and a true. Well, I'm going to use another identity and write P or Q. This identity has a fancy law name, and it's called an identity law, which is not I don't think very illustrative or not very descriptive of that particular law. But I understand why that's the case. Because for an and expression to be true, both sides have to be true. If we have a true on one side, then the truth value of this compound expression doesn't matter about this right-hand side because it's already true. All that matters is this left-hand side. So then I can just reduce it to this left-hand side right there. Fantastic. So I've been able to take that compound expression and I reduced it down to this. And we can immediately see that therefore, no, this thing is not a tautology. And it's not a tautology because, for example, we have that this thing is false right here. I've taken this compound expression, I've applied my identities, and I found that it was equivalent to this simpler one, and so I could easily find values that make this thing false. And since we have at least one assignment of truth values to my variables P and Q that make that compound proposition false, therefore, no, it is not a tautology right here.